Okay, with this video, we'll start looking at derivatives of inverse trigonometric functions. And the first one we'll look at is the derivative of the arcsine, or sine inverse of x. And that is 1 over the square root of 1 minus x squared. Now, in the event that we're talking about a function of x instead of x, and we call that u, arcsine of u, where u is a function of x, then that would be 1 over the square root of 1 minus u squared, whatever u happens to be, times the derivative of u with respect to x. Alright, so let's take a look at number 41 and see what we have. We're looking for the derivative of 2 times the arcsine of x minus 1, and so the 2 is just a constant multiple. The x minus 1 is the inside function, but its derivative is just going to be 1. So even though it is a function composition, it's not going to affect that much. So we start with the constant multiple, it's 2, and then it's going to be 1 over the square root of 1 minus u, which is x minus 1 squared, and then times the derivative of u with respect to x, and that's just 1. So all we really need to do with this is to simplify that radicand in the denominator there. And let's see what that might look like. So when we expand out that x minus 1 quantity squared, we get 1 minus the quantity x squared minus 2x plus 1. And when we distribute the negative 1 to each of the terms in there, I think you can see that the 1 and the negative 1 will both cancel, will zero out, and would be left with something like 2 over the square root of 2x minus x squared. And I think that's all we have for that. There's not a whole lot that can be done. You can factor out an x, and you would get x times the quantity 2 minus x under the radicand, but that doesn't do a whole lot for us. But at least it will show us where the derivative doesn't exist. For example, it won't exist when x is 0, or when x is 2. And of course, when you have a radical in a denominator like that, the radical expression has to be greater than or equal to greater than 0. It can't even be equal to 0. It has to be greater than 0. And so we could talk about things like what is the domain of that derivative. But finding the derivative was good enough for right now. We're done with that part. Alright, in number 43 we're looking for the derivative of 3 times the arc cosine of x over 2. And if you recall, the derivative of the arc cosine is just the negative of the derivative of arc sine. And so we're going to have 3 over, and it's going to be negative, so I can write that in also. Negative 3 over the square root of 1 minus x over 2 quantity squared. And we can simplify that up a little bit. Sorry, we also have to multiply that by the derivative of x over 2, which is 1/2. Now, what might be done to simplify that? Again, this is not extremely important, but it is the algebra part of it. So let's see what happens if we were to expand. So we would have something like negative 3 over 2 times the square root of 1 minus x squared over 4. And if we were looking to maybe have some common denominator there, it would be 4. So we would just multiply the top and bottom of 1 by 4. Now, the square root of 4 minus x squared over 4 can be broken down into two radicals. And then the square root of 4 is just 2, and that 2 is going to cancel with the 2 in the numerator of the denominator. So I guess to whatever extent that was beneficial, it does look a little bit neater than what it was originally over there. So for number 41, we have 2 over the square root of x times quantity 2 minus x, and for 43, we have negative 3 over the square root of 4 minus x squared. We'll go on to 45 in the next video.